Hello friends, good day. Today we'll be talking on critical sets, a topic in Latin squares and Greco-Latin squares. Yes, last week also I talked about a topic in Latin squares and Greco-Latin squares, and that continues. So Latin square started with the structure by the French mathematician Mr. Jacques Sozenham in 1726, where he arranged the 16 honors cards of a playing deck in a 4 by 4 array such that in any row or in any column there is no duplicate either in the suit or the denomination. This is a hard arrangement. The probability of getting this arrangement randomly is very low, once or twice in 2 billion tries. That's the level of the uh, probability of success. And he public he it came into being in 1726, and in late 1700 it reached Euler. The 6 by 6 version of it, as the problem of 36 officers problem, Euler failed to construct a 6 by 6 array, and he is the first person to attack this problem systematically. He created Latin square. He coined the terms Latin squares and Greco-Latin squares. And then in 1959, Euler made a conjecture the Greco-Latin square doesn't exist for the order 4k plus 2, which was disproved by Professor Rajchandra Bose, Sharadchandra Shankar Shikhande, and Eldest Tilden Parker in 1959. They disproved the Euler's conjecture and proved that Greco-Latin square exists for all orders except 2 and 6. In 2023 January, I had a communication with Professor Rita Saharai, Professor of Indian Statistical Institute, and our teacher, who gave me two papers to study on critical set. What is the critical set? A critical set of a Greco-Latin square is the minimal set of double-digit entries in an n by n array that defines the Greco-Latin square of order n uniquely. So you put some numbers and the rest could be deduced to complete the Greco-Latin square. So that's the concept of critical set. I extended the idea of the critical set to Latin squares also. So this is my study of the size of the critical set, the minimum size of the critical sets, and these are the numbers I got: 1, 2, 4, 7, 12, 19, 28, 39, 42 for Latin squares. And for Greco-Latin squares, there is no entry for 2 or 6 because our Greco-Latin square of order 2 and order 6 do not exist. For the others, I have the minimum size of the critical set so far is 0, 3, 4, 6, 18, 28, 37, 46, and I could do my experiment here, and I'm trying to lower the bounds of the critical sets, the minimum value. And I have the proof of these numbers, and as I have these Latin squares of order 3, 4, 5, 6, 7, 8, 9, 10, and these are the critical sets. When you put 0 and 2 here, the rest could be deduced from the order 3 Latin square. When you put 3, 0, 2, 2 here, you could deduce the rest of the entries of the order 4 Latin square. So I have the proof behind my numbers, and these are for the Greco-Latin square. For Greco-Latin square of order 3, the minimum size critical set is 0, 0, 0, 2, 1, 0, and the rest could be deduced uniquely from these three given numbers. And this is my discussions on the critical set of Latin squares and Greco-Latin squares. Now I was working with the critical set of Latin squares. If you go to order 3, this is not a critical set. Okay, this is not a critical set. My emoji is not smiling, but this is 2 and 1 is a critical set because you can deduce the rest of the entries from these given two numbers. And the probability of getting I have I have played it for 40 times, and among them 21 times I could get a critical set. So the probability of getting a critical set for order 3 is 52.5, and my current waiting time is to get a critical set is 3 for order 3 Latin square, and the average waiting time is zero 0.9, which is below 1. So for order 4, I have played it 53 times, out of which 5 times I got the critical set, and the probability of getting a order 4 critical set is 9.43%. My current waiting time is 1, and the average waiting time is 9.4. I could try to get a critical set of order 4. Let me see. Maybe I'll stop the video and we'll come back whenever I get a critical set. Okay, I have got a critical set of order 4 Latin square. The waiting time is 17, average waiting time is 10.6, and the probability of getting out of 70 I have got 6 successes, and the probability is 8.57%. Now for order 3 Latin square, for any other critical set, one can use this transformation: row interchange, column interchange, clockwise rotation by 90 degrees, horizontal reflection, vertical reflection, forward diagonal reflection, backward diagonal reflection, to get back a single structure like 1, 2. Any other critical set of order 3 could be transformed by this transformation to be into this, to look like this order 3 critical set. So basically all the critical sets of order 3 are same. Similar thing is true for 4. So I have got a 3 1 1 2 critical set of order 4, but here it is now. Let me do a row interchange, then let me do a forward diagonal reflection, let me do a row interchange 1 3 3. See, this critical set looks like this one under the under these transformations. So these are basically same, but that is not true for order 5. For order 5, one critical set looks like 2 3 2 3 3 5. There are 2 2s, 2 3s, 2 5s, and 1 4. But another critical set is like 2 4s, 2 5s, then 1 2 3. So 2 into 2 plus 3, and here it is 3 into 2 plus 1, which cannot be same. So this does not hold for order 5. There is only one critical set for order 3 Latin square. There is only one critical set for order 4 Latin square, but order 5 there are multiple critical sets. One can count them. Anyway, I'll stop here. Like, comment, share, subscribe my video. I am available for one-to-one sessions too. Thank you.